joining.
Here we go. We are already having fun behind the scenes.
Yeah, we are.
Awesome. So good to see everybody. Awesome. Hi, Audrey. Good to see you. Pete's joining us today. Good to see you too. Audrey, you getting out and flying much?
Yeah, I'm gonna go after this meeting. Gonna go fly.
Yay. And so drone is back and you're back in the air again. That's a good thing. Awesome. Anybody else have any great drone stories to share with us? Hi, Sharon. How are you? Amazing day. Excited. Love our Tuesday mornings. So exciting. And gonna make sure. Hi, Mark. How are you?
I'm good. How are you, Desi?
Fantastic. Better now that I see you here today. You have any great drone stories to share?
No, but I did my 60th MS bike ride this weekend.
Well, congratulations. Yes, there's a hurdle. Awesome. All right, Jeremiah. Hi, how are you?
Good. Just about recovered from the expo. So only what, 3 weeks later? That's record timing.
I bet that's a lot to unwind from, right?
Yeah, no, like we always say, there's just nothing like getting together and still chasing down some stories from that event. So it's just great to be able to connect with everybody there.
Awesome. Yes. And I've heard nothing but good things.
Oh, good.
Yeah. And so now what has been the review? What has been some highlights that you have heard?
The opening keynote had some really positive feedback. That was one Gretchen West moderated, and we're actually doing kind of a part 2 of that because they only had half hour and Ken Stewart wasn't able to join. So we're gonna run that back. And then had some really positive feedback from a lot of the case studies that were presented across the program. So that was kind of the big highlights. And then like every year there was everybody liked to be able to see the technology on the floor. But then too, Desi, your pilot session, like that was a standout for us. We're looking through some of the surveys and just really good reception in terms of wanting to do more, kind of take that to the next level. So that's all stuff that we're going to be talking through and talking with all of you about to see what makes sense for everybody.
I love it. I love it. All good news. Moving.
Sensei, I might have a story.
You do.
All right. Have a story. We have a story.
Yeah. So, I'm out test flying for, the company. I'm at Black Mountain. I have an entire park field available to me. There is ample space. You could have taken your 4x4 and just drove all around. Needless to say, I'm in the middle of a flight test, and a couple old ladies just kind of walked into my flight area. I've got a table, I've got a computer. You could see that I'm actually actively flying a drone midair, and they just squatted right where I was flying. And the reason why I'm bringing this up is because this was an incredible test of patience. I had to take that deep breath. I had to bite my tongue from this whole job has literally changed my character from the previous occupations that I've had, which had, zero tolerance. I actually found myself challenged with just how do I deal with this situation with people who just dropped their backpacks and just sat where I was flying. So I had to turn my attention and, move the drone to a different part of that airspace. And it didn't matter where I went. They were just like, "Are you taking pictures of us?" And I just had to be like internally, I'm like, "Please do not talk to me. I hate you," kind of thing. But at the same time, I kept my patience. I kept my cool. I flew in a different part of the park, landed, collected my data, packed up. And when I'm grabbing my table, which is literally the last thing I needed to put in my car, then they got up and left.
Ah,
And the whole time I'm thinking, what was that?
Johnny,
so
Johnny,
All right.
that's not a real story.
yes, we have had it, and that's where professionalism comes in. And all right, people always want to know, what are you filming, right? All right, so I do have to get the ball rolling because I don't want to take up the time of our amazing spotlight speaker that we have here today. I do have one really quick announcement that I am going to put into our chat really quick, and it's especially pertinent for today because there is only 1 week left for the LP360 user conference, right? Isn't that perfect knowing what we're going to be talking about today? So really quick, like I put the link into our chat. It's October 9th through the 11th. And I even put in a discount code. The registration link, so we hope to see you there. All right. With that, I am going to segue over to our amazing spotlight speaker. We have Bruce Markman with us here today, and he is San Diego State University graduate student researcher, and he's going to be sharing with us today the residual dry matter with UAV LiDAR and hyperspectral imaging. And it is an amazing use case. So I am excited to have him here today. Bruce, I'm going to segue over to you and make you spotlight for everyone.
All right. Thank you so much, Desi, for the wonderful intro and mentioning the LP360 user conference. I'm a LP360 user myself. It's a great software for all things UAV and LiDAR processing. So that's a great opportunity. I actually haven't heard about that conference, so it could be really cool to check it out at some point.
Awesome.
But yeah,
It was perfect segue, wasn't it?
exactly.
Awesome.
Let me just share my screen here. Go into
Okay.
presenter view. There we go. Can everyone see that okay?
It's not in presenter view yet. It's with the slide deck on the side. There you go. You got it.
Excellent. All right. Thank you so much. Yeah, so my name is Bruce. I'm a second year master's student at San Diego State University in the Department of Geography. My research is kind of at the intersection of environmental science and remote sensing. And my bachelor's is from UC Davis, where I studied GIS and environmental science as well. And yeah, this has been an awesome project to kind of combine my two passions and kind of get a lot more hands-on experience with UAVs and data processing and data analysis and things like that. And so the title of my presentation today is Estimating Residual Dry Matter with Remote Sensing, Enhancing California Rangeland Management and Monitoring. So residual dry matter, I'll go into what it is in detail during my presentation. I know it all sounds very technical, but don't worry. By the end of this, you'll be an expert on residual dry matter and an expert on how to apply remote sensing technologies to estimate it and map it and quantify it across rangelands. So the outline for my presentation today kind of has 4 stages, roughly. So I'll be providing a brief overview of what rangelands are, specifically to California, but also kind of why they're important and how they're threatened today. It's definitely turning into a more sensitive ecosystem as the days continue. I'll talk about adaptive management and monitoring, how those two are critical for combating grassland threats and degradation. I'll talk about what residual dry matter is, as in the title of this presentation. We'll also talk about remote sensing approaches for mapping and quantifying residual dry matter. I'll talk about kind of the traditional approaches, what has worked, what hasn't worked, and then I'll talk about what we've been doing for this research and what's worked and what hasn't worked for us using novel approaches. I'll introduce a pilot study that we conducted this past summer at Dawson Los Manos Canyon Reserve. It's a reserve managed by UC San Diego, University of California, San Diego. here in San Diego County, and where we conducted initial test flights of our new UAV LiDAR sensor, as well as preliminary hyperspectral data as well, and how that was a precursor for kind of a large scale study that I'm focusing on for my thesis at the Jack and Laura Dangerman Preserve. Dangerman should ring a bell. That's those are the Esri people. They basically donated a huge plot of land to the Nature Conservancy a couple of years back, and it's a great place to conduct remote sensing research because they have a long history of remote sensing studies and using and they have a lot of rangelands there as well. So it's kind of the perfect ground to test this research. And then I'll talk about kind of the next steps with this research and kind of where I envision some of these things going. All right, so California rangelands. So they cover a substantial portion of the state's land area. Around 63 million acres are rangeland in California. They occur both on private and public lands. And so what a rangeland is basically grassland, shrubland, woodland that's managed for grazing. And so that's kind of what differentiates, a typical grassland, like a natural grassland you see from a rangeland, is that a rangeland is specifically managed for grazing and is, managed. And in California, and I guess across the entire Western United States as well, large percentage, is dominated by invasive annual grasses that were introduced by early European settlement. And so invasive grasses means grasses that are not native to California ecosystems. They were brought in by early European settlers. And what an annual grass is you can see in this second picture right here from the top, kind of in the middle right there, it's showing, brown. In California in the summer and the fall, you drive down some of these freeways, you see everything is brown. You think fire hazard, you think like, oh my God, everything's going to catch on fire. But it's kind of a natural process of these grasses where they grow throughout the growing season. They grow. And then come summer, fall, they start to senesce and they start to naturally turn brown. They lose their chlorophyll and they stop photosynthesizing. So they turn this into this brown color. And so rangelands, even though they're highly modified by humans, they're historically heavily grazed. They do provide a lot of ecosystem services, and an ecosystem service is basically a natural good or service that an ecosystem provides to humans and wildlife. So, for example, to humans, rangelands are really important because they provide livestock forage, and it's kind of the foundation for the dairy and cattle industries that our society relies on. And kind of ecologically, they're really important because they store a lot of carbon. They cycle a lot of carbon. They also are really important for flooding and erosion prevention. And they also provide habitat for a wide variety of species like mammals, birds, insects, reptiles, and things like that. So they're really important systems, and they're honestly really important systems that a lot of people don't take into consideration when they think of ecosystem services. And so worldwide, not just in California, but this talk is going to be focused on California, rangelands are threatened. So one of the biggest threats to rangelands is overgrazing. Essentially, it's when these ecosystems are grazed to the point where the land becomes unproductive. It starts to slowly turn into a desert. You stop getting these productive green grasses, and nothing can really grow there because it's so heavily trampled, it's so heavily grazed uncontrollably. It causes soil erosion, and it causes all of these adverse side effects from overgrazing. Invasive species, also a big concern. A lot of these species choke out native plants and create these kind of like monocultures of invasive species that make it very difficult for natives to actually survive. Increasing drought and fire frequency something that most of us are very familiar with in California, and serves as a really big threat to rangelands. And all of this, the increasing drought and fire frequency is amplified by climate change. And it creates kind of this feedback loop. And, it's becoming very challenging to manage these rangelands across the state, especially when you have these private and public entities managing such large swaths of land. It's very difficult to, properly and sustainably manage those properties. And so adaptive management is kind of the key to sustainable land management. It's kind of this model, this iterative learning practice that's kind of bound by exchanging ideas and science to inform management. And so where my research lies is kind of in this field work models and validation portion of this adaptive management model. You can honestly write a thesis about any one of these boxes. It's a really robust framework. But where this research lies that I'll be talking about today is, okay, how can we improve the field work and the models that go into monitoring plans, that goes into decision making for sustainable land management, and how can we preserve the ecosystem services and biodiversity values that I talked about earlier. And so residual dry matter is basically an adaptive management proxy or an index that's used to assess cattle grazing, but it's also used to assess fire risk, forage productivity, past management, and soil health. Overall, it's used as an index to assess rangeland health. How is a rangeland reacting to various levels of grazing? How are fire fuels a risk to a property? Things like that. It's measured at the beginning of the growing season, so late summer, early fall, when grasses are already senesced and slowly starting to grow back. And typically the way it's measured is you have these land managers or field workers going out into the field and clipping either to a square frame plot or a circular hoop that's 13.25 inch diameter. You weigh the amount of dry matter that's been clipped in that hoop, and then you convert that value to pounds per acre to kind of, it's a quick and dry way to assess how much dry matter is on your property. And it's worked very effectively in the past, but it's worked very effectively in the past, but it's obviously, a very time cost intensive, and it's very hard to, sample a lot of these across a property, especially when you're a land manager working with thousands and thousands of acres of land. It's kind of like a really crude estimate of residual dry matter. And so kind of ecologically, residual dry matter, I kind of hinted on this earlier. It's that dry plant material that does not photosynthesize. That's why it's brown. But it's a very, very large component of the overall biomass in these systems. So if you look at this photo over here, I mean, you have some oaks, but it's really dominated by these grasses. So it makes up a huge chunk of these ecosystems. And it's also been recent paper has been published saying that it's now becoming this essential climate variable by the global climate observing system. So what's the problem here? I kind of hinted at this earlier. The ground-based methods for estimating residual dry matter and kind of collecting that data is really time intensive, it's expensive, and often it's really subjective. So people, clip the dry matter differently. People use different, some people use the hoops, some people use the squares. There's no really standard way to estimate residual dry matter. There's various different protocols that people follow and stick to, but a lot of that is kind of, what has been done in the past is what they continue to do now. And so another really important thing to mention that's problematic with these ground-based estimates is that they provide retrospective measurements of RDM. So basically it's the accumulation of like plant material through the previous growing season, which makes it really hard to actually, implement strategies during the season where it actually matters, like the subsequent growing season, because it just tells you, what has grown on the property this past growing season and not what will grow in the future season. And I also mentioned this earlier, these collections, they're often sparsely sampled across large spatial scales. So when you're sampling, at really far distances and kind of extrapolate those values, you get really, coarse estimates of that residual dry matter. And so remote sensing is super advantageous for land management because it allows for the continuous collection of environmental data without cost and labor intensive field work across large and often inaccessible areas. And so when you think remote sensing, you think, okay, we can use satellite imagery, we can use drones, we can use planes, we can get all of this exhaustive, spatially exhaustive environmental data, often in a very cost and labor efficient way. And so two of the primary kind of remote sensing methods that are used are passive or optical imagery that relies on sunlight as an energy source. So when you think of a camera, like a photo camera, only really works if you have sunlight or if you're using a flash, but it doesn't create its own light source. And typically, remote sensing studies that utilize optical imagery is they correlate the biomass, which is RDM, that's either collected in the field or in a lab, with the reflectance that's from this imagery. And also active imagery. Mentioned earlier, LP360 is used for LiDAR. What is LiDAR? It's basically this remote sensing technology that emits pulses or lasers. It emits its own energy source, so it does not rely on sunlight as an energy source. And it gives you really useful information on structure. You can build kind of these three-dimensional models with LiDAR data. And the way remote sensing is or the way RDM is quantified from this is basically correlating biomass with canopy height or canopy structure. And so diving into optical imagery, quick little crash course. There have been a lot of studies that have tried to use traditional multispectral imagery. If you think of NASA's Landsat, that's kind of super accessible, super common spaceborne imager that's used for a lot of environmental applications. It's not very useful. It's useful for green vegetation, but it's not very useful for brown vegetation. And the reason is, you can see my laser pointer right here. The reason is there are not many spectral bands in traditional multispectral imagery like that on Landsat. So basically you have bands that are kind of placed sparsely across the reflectance spectrum, and then you kind of get these coarse averages across. So it's really hard to tell materials apart. Hyperspectral imagery, unlike multispectral imagery, has hundreds of bands. So you're able to get kind of this detailed curvature of various materials that you're looking at. And so when you look at this figure on the right, you can see a typical reflectance spectrum of green vegetation, dry vegetation, and soil. And so with the hyperspectral, you're able to tell the dry vegetation and soil apart. Often with multispectral imagery, that's really hard to do. And so a lot of studies that have used multispectral imagery, they tend to really overestimate the amount of RDM because it's mixed with that background soil. It's really hard to tell it apart. And so for part of this pilot study is understanding, okay, how can hyperspectral imagery be used to quantify, to directly measure the amount of RDM? So I mentioned earlier, Dawson Los Manos Canyon Reserve is this reserve in San Diego County that's managed by the UC San Diego Reserve System. They were kind enough to let us do a lot of these pilot research on their property this past summer. That's actually where I met Desi, who helped out with some of the field work. But they have this, it's a really diverse kind of ecosystem at Dawson. They have like a riparian area, an area with like a creek. They have a lot of mountains and oaks, and they also have this pasture that's has a lot of weeds, as you can see here, but also has a lot of RDM. So it's kind of the perfect place for us to test some of this technology. And so we used this device called a reflectance spectrometer. It's not a camera, but it directly measures reflectance of different materials. And it has 1,024 spectral channels or bands. So I mentioned earlier, Landsat only has 9 spectral bands. This thing has 1,024. So you get super, super detailed information about different materials that you're scanning. And so this figure right here basically shows how you're actually able to tell apart the bare soil in the background from the RDM within the hoop. And so we went out into the field and we got kind of randomly stratified 15 samples of these RDM hoops, ranging from 20 grams of dry matter within the hoop to 192 grams, a lot of dry matter within the hoop. And basically, with each of these, we got spectral signatures of the amounts of RDM within each hoop. And so overlaying all of these spectral signatures on top of each other, you kind of get this mixture, right, of blue. Everything in blue is low RDM, so 20 grams, 25 grams. Everything in red is high RDM, so like 192 grams, 153 grams. And okay, so how do we actually get valuable statistics from these spectral curves? Like, how can we actually correlate the residual dry matter mass with the reflectance from the spectra? And so vegetation indices, some of you might have heard of NDVI. It's a really common one that's used to assess like vegetation greenness and crop health and things like that. Not super useful for this kind of system because we're looking at brown vegetation. And so really useful indices for kind of isolating, spectral features, absorption features on the reflectance spectrum for brown vegetation is the cellulose absorption index, the lignin cellulose absorption index, and the normalized difference lignin index. And all of these basically take a portion of the reflectance spectrum and basically quantify it so we can directly relate it to the RDM. And all of these have been used in one way or another for RDM or like non-photosynthetic vegetation mapping purposes. And to reiterate, these are specific to hyperspectral imagery. Very, very few, if not none, no multispectral sensors actually have bands that are in this part of the reflectance spectrum. So this is kind of where hyperspectral shines. You can calculate way more indices because you have way more bands, especially in this shortwave infrared region. And so kind of zooming in on the area where these indices are calculated, we're looking at 2 of them right here, kind of zoomed in on that 2,000 to 2,400 nanometer range. If you kind of look up here, you could tell apart, okay, that's the low RDM. You could tell those apart. But once you get to medium and high RDM, they're totally intermixed right there, just visually looking at the curves. And then you're kind of seeing the similar pattern throughout the curve. It's really hard to tell apart the different RDM amounts just looking at the spectral curves. And this is what we call saturation with the medium and high RDM amounts. It's really hard to tell apart those quantities just looking at the curves because they're just all intermixed right there. And so when you actually quantify it, when you do a regression between RDM on the y-axis and each index on the x-axis, these scatter plots kind of confirm what we're seeing, right? There's not much of a relationship between those reflectance values and the RDM. And so this is another index that I shared earlier, normalized difference lignin index, seeing a very similar pattern here. We're seeing that saturation occurring throughout this region where these spectra are all intermixed. And it's really hard to distinguish RDM biomass just by looking at these spectral curves alone. And so similar thing right here. Sorry, I'm going to take a sip of water here. you're seeing a similar pattern with this normalized difference lignin index as well. Okay. Just looking at spectra probably isn't the best option for quantifying residual dry matter. What about active remote sensing? We mentioned LiDAR has been used to estimate it, and it's offered promising results in the literature. Let's test it. So also at Dawson, we used UAV LiDAR to similarly quantify RDM in those hoops. And so for those of you who are interested in what LiDAR unit and what drone platform we tested, it's the GeoQ TV540 UAV or TV540 LiDAR sensor. And the platform is a DJI Matrice 350 RTK. And you can see right here, we have a GNSS base station as well. That's what we used to geo-reference the, the LiDAR. And also to geo-reference each of the individual hoops that we marked with a receiver. And so kind of the goals of this pilot study is, okay, LiDAR, how can we actually use LiDAR to get these measurements? Our department got this new LiDAR unit, but there's not really anywhere in the literature where someone has actually tested this for this particular purpose. So we went ahead and tested 3 different flight parameters, low and slow, high and fast, and something in between, to kind of see, okay, what would be the optimal point density to correlate the canopy height, the canopy structure within each of those hoops with the LiDAR data. So here's a little clip that I put together of what these points actually look like. When you spin them in 3 dimensions, you could kind of see you know, this is the area that we launched from. You can see the launch pad. And each of these are individual little tiny points that give you X, Y, Z data on structure of various materials and vegetation and things like that. And you can see all the weeds right here. You could, see the variability in the topography. So this is super high density point data. And so highest density with the LiDAR was, just around 9,000 points per square meter. So for every square meter, you have 9,000 individual data points that give you X, Y, Z, which is crazy. That's so dense. And so to kind of analyze this data and kind of the process for how we extracted statistics from LiDAR is we did 2 flights for each parameter. We flew the LiDAR first to get the height of the canopy. Then we clipped each individual plot down to bare soil. Flew the LiDAR again, and then took the difference between the pre-clipping flight and the post-clipping flight to get the canopy height for each individual clipped area. And then we converted that to a raster format, resulting in about 100 pixels per each individual clipped area. And then we're able to get statistics from that. We're able to get information like mean, max, sum of each individual cell that represents canopy height. And so looking at the 30-meter flight, we're able to see kind of from these statistics, especially from the sum and the mean, pretty great linear relationship between, sorry, I'm losing my voice. Pretty strong linear relationship between canopy height and RDM. Seeing a similar with canopy height at 60 meters with RDM, similar results at 120 meters with RDM. And this is really encouraging because you're able to scale our results to a higher altitude and still not lose accuracy in the study. And so all of this was a precursor to a large scale sampling effort at Jack and Laura Dangerman Preserve that I mentioned earlier. Here's some photos from where we just were. We just got back from here. And kind of the next steps, we're going to be exploring linear and kind of machine learning approaches to correlating RDM with the hyperspectral and the LiDAR data. We're going to be using environmental variables as further predictors to estimate RDM. And we're also going to be scaling these results to kind of get broader estimates of RDM to airborne and spaceborne data. And so none of this would be possible without this amazing team. And yeah, this was definitely a collaborative effort, and it would not be possible for me to do this alone. So thank you to everyone who helped me with this study. And thank you, Desi, for inviting me to present some of this research today to this awesome community. And our research was actually featured in a newsletter for the UC San Diego Natural Reserve System, which was really cool. And yeah, here's my email. If you have any questions, feel free to reach out or let me know today in the chat.
Oh, that's fantastic. It is just amazing information that you're providing. I love the work you're doing as far as moving forward and the results and the outcome that can come from this. So thank you. Thank you very much for all of this. And yeah, quite the team you got there. I think a couple of them are actually online here. And over in our chat, we have a lot of celebration going on and a lot of great information. Do you want to drop down the PowerPoint now, and we can maybe look and see and open it up if anybody has some questions? I think we did see a few questions popping in. I will have to actually scoot way back up, I think. One of the ones was about the RTK unit. I think Audrey was asking about that. And if you could just elaborate a little bit more about that setup that you had in the network and such.
Totally, yeah. Sorry, I'm losing my voice a little bit, so I might sound raspy.
That happens after you've been talking for an hour.
Yes.
I found it, Desi. Bruce, 1 second. You can take your voice gives a break for a second. So Audrey's question, if it makes a difference, is considered an N-trip network instead of base station, or would none have had the correct accuracy? I'm just looking into RTK with N-trip now. So that was, and I'm gonna back out of that one. Let Bruce take over now.
Yeah, that's a great point. I'm not entirely sure, to be honest.
That wasn't the part of the analysis you were doing. All right. Well, we do have other comments and questions in here. I'm going to roll down a little bit. Everybody has just been so grateful for the knowledge that you are sharing and moving forward. So while we're skimming through all of our chat, because there are a few questions coming up, can you share what would be your ultimate goal from this? Now that you've gathered all this great information, what are you hoping to make your next steps and the ultimate goal? I know it takes many steps.
Many steps, yeah. The ultimate goal would be kind of to make a product that's usable by land managers. You know, a lot of this technology is really expensive and it's really hard to analyze this data. You need a lot of technical experience, but actually implementing it into practice, making it usable for broad scale estimation of RDM and actually implementing it into policy is my ultimate goal. And this is kind of where I was going with kind of enhancing these models and scaling into airborne and spaceborne data, because a lot of these new hyperspectral sensors, they're on spaceborne platforms now. NASA EMIT, for example, is a spaceborne hyperspectral sensor. And so how can we actually, confirm what we're seeing on the ground with the spaceborne data? Because a lot of that spaceborne data too is free and publicly available. So if we can find a way to actually correlate that to the spaceborne imagery and validate it and calibrate it and actually create a product that's usable to inform policy, that would be the ultimate goal with this research.
Ah, the bigger picture. Ah, I love it. I truly do love what you're doing. I have my own heart that goes out to the land management, and just seeing that the use case of just regenerating the ecosystem and such like that is just phenomenal. And having this opportunity and the finite details that you provide is just phenomenal in this case. So share a little bit more about your experience and the teamwork, because you did have a phenomenal team. And so share a little bit more about that teamwork of going out there and putting this whole project together. You had an amazing team out there.
Well, here's my team right here.
Okay. Love it. And some of them are on
Yeah,
here.
some of them are on here. Yeah, it's been, working with a team is essential for a project like this, like learning from other people, building these friendships, building these connections. It's been invaluable, honestly. And I mean, yeah, I'm so grateful to have such a hardworking team. Everyone just worked so hard. Everyone was so supportive and willing to help. And we just had a really good chemistry throughout the entire process. So
Awesome. Wonderful. So Jennifer Pigeon made a comment in our chat. Definitely want to check in with Jennifer. She's extremely knowledgeable when it comes to LiDAR, being LiDAR pros. If you're looking for accuracy with the RTK and TRIP networks, definitely help with the alignment. It's a matter of how accurate you are looking for and what you want to accomplish. So she had made that comment in there, and she also put in her contact information. And so she made a comment as well about wonderful research project. She's been working with a international organization looking into LiDAR for tree health. That's excellent too, Jennifer. LiDAR for tree health, super exciting use case. Do you plan to do another use case like this?
Most likely, yeah. It would be really cool to kind of test this in different systems. There's kind of a booming field with estimating biomass or with remote sensing, because it's this really important variable for fires and restoration and things like that. So yeah, it's definitely a broadly applicable research method where you use hyperspectral to get information about biophysical properties, and you use LiDAR to get information about like structural properties of vegetation. And kind of going back to the to the georeferencing question, for the Dangerman campaign, we actually switched things up a bit. We did not use a receiver, or we did not use a rover to mark each of the quadrats or each of the hoops. We actually used this irrigation tubing around each individual hoop, where we used the true color imagery from the LiDAR sensor to kind of validate what we're seeing in the LiDAR, because the GeoQ TV 540 actually has a true color camera that colorizes the points. You can also use it to create an ortho mosaic of the exact scene that you're scanning, and you can visually identify each individual hoop.
All right. So question was answered, but just in case some people can't see the chat, what LiDAR payload did you use? And Pete has said that it was the TrueView 540, and then TV 540. Got it. Awesome. Awesome. Have you tried various types of LiDAR as well, or was this the resource that you had available and it's top of the line and that's the choice you had, or have you actually had an opportunity to try different types of LiDAR systems?
Do you mean like discrete versus full waveform, or
Well,
just
I know
different sensors?
so having yes, I guess having the opportunity to use different sensor, obviously more advanced, like you were talking about how much the light it penetrates versus some that don't penetrate quite as much. So through this same process, have you had different opportunities and seen the advancements with the latest technology?
We really did with this project dive into using this TV 540, which is a really sophisticated sensor. But I think it would be really interesting to test this with like a more affordable LiDAR to see, like, do you actually need this super expensive technology to do this kind of study?
Yeah, I think that would be fantastic. Just and seeing this transition across the United States, knowing that it is such a needed technology and use case for all the states. And so that would be awesome moving forward. And let me just double check our I did miss one from Karina. There's research in Finland with VTT that you might want to compare the data with. Not sure if this is useful or helpful, but sharing just in case. Just in case, Karina, do you happen to know the link and you could share? Because we are all about networking and sharing here, right? Jennifer said TV 50 is amazing payload. Good bang for the investment of it. Yes, she is definitely the LiDAR pro. Awesome, awesome. So now I know your next step is also doing a presentation with this. So that's coming up here shortly, isn't it? Where you're taking the same data and information and presenting it.
Yeah, I'm actually doing my thesis proposal defense next week. Hopefully I won't lose my voice during that.
So is that going to be live or in person?
That's going to be in person, and it's kind of just going to be my thesis committee, because they will be asking me very specific questions related to this research, and it's kind of the next step for me to like advance to a master's candidate from a master's student.
Oh, fantastic. So awesome. What an opportunity. And then, like I said, I love what you are doing. All
Hot
right.
Thank
tea with
you.
honey. Just bring that with you. Little swig here and there, you'll be good. Hot tea
Yeah,
with honey. Good to go. Mhm.
hot tea with honey. Noted.
There you go.
Well, thank you so much to everyone for showing up today. And yeah, thank you, Desi, for just being, so inspiring to the drone community. Like everything you've been doing with Women in Drones and Girls Gone Flying and all of these other projects that you're on. It's awesome.
Well, thank you. Thank you for joining us. Thank you for sharing. I love, keep in touch with us. I want to know how it goes and see your next steps. All right.
Will do.
How
Yeah.
your presentation goes. Yay.
Thank
We
you.
want to know how
Yeah.
it goes. Definitely. So love that. Yes, they're already saying ditto on that. They love it. They love the information that you provided. Thank you so much. And I want to do a really quick reminder that these sessions are recorded, and it does take Johnny a couple weeks to get them out, but he gets them out on the spare because he has a full-time job. And so if you missed it or want to watch it again, then you have an opportunity because they do get recorded. So Bruce, thank you so much. Thank you for all you're doing. Thank you for sharing with us today. Amazing.
Save the chat.
Thank you, Bruce.
Thank
Great.
you, everyone. And here
Yeah.
is my email for those who want to connect later down the road.
Awesome.
Thank-
I will go put that in our chat.
Sweet.
I'll put that in there. That kind of wraps it up.